You're here to create a game, so let's dive right in. On screen, you're seeing the gameplay you'll be building by the end of this video. No paywalls, just solid game development with GDevelop. Everything you need, from the engine to the assets, is included completely free. If you're ready to begin your quest towards the Triforce, then our first step is getting started with setting up the game engine. Alright, you made it this far, which means you're ready to get started. First, open up your favorite browser and head over to gdevelop.io. From here, you've got two options. Download the app using this lovely button, or start creating directly in your browser. Either way, you'll land on a screen like this. I recommend taking a moment to create a free account, which unlocks cloud saves, perfect for picking up your project from any computer. If you're going to stick with the browser, you'll have to create an account no matter what in order to save your projects. But with the app, you can always save it locally. Once you're ready, navigate over to the Build tab and click on Create a Project. You'll see several options. Let's start by selecting Desktop and Mobile Landscape. Then a project name. I'll be going with Zelda Tutorial. Next, choose where you want to store your project. Cloud storage is great for easy access, but if you're using a local PC, pick the folder where your files and assets will go. We'll skip the AI generation, then select Optimize for pixel art and ignore Allow players to authenticate in-game. Now we can go ahead and click Create Project, and we will be taken to the scene of our game. Alright, we've made it to the game engine's scene page. This is our game's visual editor, where we'll design and organize our levels and characters. For now, let's close all the toolbars, and we'll dive into those features in detail as we begin adding to our game. Looking at our scene, we see an endless gray area with a black box representing our game's starting point. Our first task will be to adjust the size of our game screen. In the Project Manager, under Game Settings, Properties, navigate to the Resolution and Rendering. Since our assets are going to be 32 by 32 pixels, our scene's width and height should be divisible by 32 to properly align with our images. For a Zelda-style world, which is 16 by 11 tiles, simply multiply by 32 to get a width of 512 and a height of 352. Below that, set the resize option to no changes to the game size to ensure a consistent view across different monitors and resolution. This next area should be already set from when we created our game, but just make sure sampling is set to nearest and round pixels should be checked. If they're not, now's a good time to make sure they match mine. Hit apply to save your changes and return. Back in our scene, we now have a smaller game window due to the resize. Since our goal is to build a full room inside this window, let's zoom in to get a closer look. You can zoom in and out using Control plus the plus or minus keys on your keyboard, or by scrolling with your mouse. When using the keyboard, the zooms will be towards the center of the screen, while the mouse zooms go towards your current cursor position. Once the black box covers about 50% of your screen, go ahead and center it. We can use the scroll bars, which appear when you hover near the edges of the right or bottom of your scene. Alternatively, hold down the mouse wheel and drag the scene around. Next, we can go ahead and set up our grid. On the top navigation bar, click on the grid icon, then choose Set Up Grid. Pick a line color, and set the cell width and height to 32, matching our asset size. We'll leave the offsets at 0, so the grid starts at position 0, 0. Apply the changes, and now back under the grid icon, we can toggle the grid on and off to show the actual grid on our scene editor. With that, the setup is complete, and we are ready to move on to the fun stuff. Congratulations, you've unlocked your first achievement. Keep studying and working hard to unlock more. Alright, let's talk about objects. In GDevelop, everything you see in-game, characters, enemies, items, you name it, is considered an object. Objects are essential building blocks for your game, ranging from simple shapes to complex characters, each with their own properties and behaviors. Let's explore where these objects come to life in GDevelop. The Objects panel. This is your toolbox for adding, editing, and managing game objects. Go ahead and open the Objects panel by clicking on the cube icon right next to the grid icon we were just using. Here's a quick rundown of the features of the Objects panel. You can click and drag where it says Objects to reposition the panel as needed. There's a search feature available, handy for larger projects, though we shouldn't need it for our tutorial. Additionally, you can add folders to further organize your objects here. Global objects are useful for sharing objects across scenes. Since our project will only have one scene though, just understanding this feature lets you reuse objects is more than enough. Then we have our scene objects. This is the main feature we'll be using. As we create objects, they'll be stored here, much like files inside of a folder on your computer. After creating objects, we can drag and drop an instance of the object onto our scene. Think of an instance as a copy of our object. Imagine the object itself as a set of blueprints. If you make a change to the object's blueprints, it affects how all future instances are created. However, you can modify a specific detail of an instance on your scene without impacting the others. Let's go ahead and create our first object. Since I'm providing the assets, we'll have to hop out of GDevelop for a second and head over to itch.io to grab our asset packs. Almost all the assets for this tutorial were created by RENDEV, so a huge thank you to her for helping us out. Now, inside itch.io, we can search RENDEV and find the Legends of Zelda-Inspired sprite sheets, or you can use the direct link down below in my description. Go ahead and download all of the assets and save them in a file so you can find them later. Additionally, while we're in itch.io, we'll also need the mountain tile set that I made. So search windstreak, ! Then look for the Link-esque background, or of course, the link is also in the description below. Great, now we're ready to begin. Back in our project, we'll click on Add a New Object in the Objects panel. We will be creating a new object from scratch, and we'll want to choose Sprite because Link will be an animated character. Change the object name to Link, then click on Create with Piskel. Warning, Piskel is glitchy on GDevelop. If you are trying to make anything from scratch, I would recommend finding a different pixel editor, then moving them over to GDevelop once you've completed your art. That being said, we should have no issues accomplishing what we need to in Piskel, since we have the created assets already and we'll just be making minor changes. So, with Piskel editor open, simply drag and drop the assets from your computer files into Piskel. We'll be using the Zelda sprite sheet, and we're going to change the import setting to import as sprite sheet and the frame size to 32 by 32, which will automatically chop up the image into 32 by 32 sections. Now on the left side, we can see 39 separate Link drawings, and on the top right, we can see the animation of Link dancing around as he goes through each and every one of the drawings. From here, we simply want to remove the ones we do not need for this specific animation. We'll go ahead and keep our first object super simple, and just keep the first animation and delete the rest, leaving us with a single frame of Link looking down. Let's name this animation as Idle Down, then click on Apply to save our changes. Voila, we have our first object. And, like we mentioned earlier, a simple drag and drop will place our new object into our scene. Now, let's talk about editing Link. Any changes we make in the edit screen will affect the blueprint of our Link object. We can open this by either double-clicking on an instance of Link or on the object itself. Let's quickly go over all the edit options for our object. First up, Properties. This is where we control the physical aspects of our object. Here we manage animations, adjust collision masks, and set up edit points. We've already made our first animation, so we have a little bit of experience in that. So up next, collision masks. These tell the engine where your object physically exists. If the mask is larger than the character, it will seem like Link collides with things before actually visually touching them. Not ideal. A smaller mask, though, can give a nice visual gap, allowing objects to appear to overlap, but not registering as colliding. This can make dodging projectiles feel a bit smoother. So I'm going to go with a slightly smaller mask for now, and we'll tweak it later if needed. Edit points are specific points on an object. You start with 2, the origin, which is where the object's position is anchored, and the center. For example, if Link's origin is set to 0, 0, the image would start at the point 0, 0, but would visually cover from 0 to 32 on both the X and Y axis, since it's 32 pixels. Furthermore, the collision would only be on pixels 6 to 26, since we made it smaller than the full image. Sometimes though, those 2 points aren't enough, so we can always create more, like an attack point for Link's sword collision. But we'll hold off on that until we have the attack animation ready. Tab 2, Behaviors. These are built-in features that let us add complex actions easily. We'll start using them soon, and you'll see just how powerful they can be. Tab 3, Variables. This is where we store all the values that might change during the game. Think health or attack power as numbers, character name or equipped weapon name as text, or even booleans like is player injured. Arrays or structures are a bit more advanced variables and won't be needed. And finally, tab 4, Effects. These add visual effects to the object like a blur or an outline. So that's all the ways to edit a blueprint, but there's also the ability to edit an instance of our object. These changes only affect the selected object in the scene. At the top of the screen, open the Properties panel screen, then select an instance of Link. Here, you can adjust things like position, Z-order, which just determines what objects appear in front or on top of the other ones when they're stacked. Width and height, layer, rotation angle, and instance-specific variables. And I know that's a lot to take in, but don't worry, we'll go over everything step by step that will be needed for our project as we get to it. Achievement. Oh, whoa, didn't see you there. I was too busy marveling at your second achievement. Great work, keep it up. So for our first task, let's get our Link object moving around the scene. First things first, we need more animations for Link. Since we're using a top-down movement system with 4 basic directions, we'll need a total of 8 animations. We've already got down idle, so next up is down walk. Let's open up our Link object again and click Add an Animation. Create with Piscal. Then we'll drag and drop the same Link sprite in, and just like before, we'll import it as a 32 by 32 sprite sheet. Next, we need to remove the images we don't need. I'll be keeping images 5 and 6, but since the numbers will change as we delete, here's a quick tip. Select the first image you want to keep. That way the yellow box shows you when to stop deleting. Go ahead and delete the remaining sprites until you're left with just the 2 we selected. Then click on Save and name the animation Down Walk. Before we finish, let's tweak a couple of things. First, we'll want to slow down the animation a bit. Right now, at 0.08, Link looks like he's had about 9 cups of coffee. So let's triple the time between animations to 0.24, and this will give us a smoother walk. Then we'll hit the button for loop, so the 2 images continue to cycle forever. Once that's done, press apply. Then inside of our Link properties, switch the animation from 0 to 1, which is simply changing it from our down idle to our down walk as the starting animation. And at the top of the scene, click preview. Now, it's not really a game yet, but you will be able to see Link's animation in action. And that's progress. And real quick, a mistake I made. I want all my naming conventions for Link's movement to be the same, which is action, at this point, which consists of idle or walk, followed by the direction. This way, later on in my project, I can call the correct animation by simply knowing the action and the direction of my object. So, let's take a quick moment to change our down walk to walk down. Now we are able to continue adding the final 6 movement animations. I will fast forward this video to save time, but you can always play the video at 0.25 times speed if you're having issues here.
Losing time, I'm fading fast. I just wanna make it last. Try to let go of the past. I close my eyes, embrace the black. Sleepless nights and headaches stack. Restlessness to hell and back. What's my purpose? What do I grab? A slippery surface, a heart attack. And sometimes you just gotta believe.
And by the time you finish your animations, you should end up with 4 single frame animations: idle down, idle right, idle up, and idle left, as well as 4 2-frame animations: walk down, walk right, walk up, and walk left. And just like with the first animation, make sure we set our animation times to 0.24 and activate the loop, as well as double checking all those names are both spelled correctly and match capitalization. Now that all the animations are set up, we just need a way to tell the game when to use them. Let's open our Link object and head over to the Variables tab. We'll create 2 new variables, one called Direction and the other Action. Both of these will be text variables since we'll be storing words like idle and down. For default values, set Direction to down and Action to idle. Make sure the spelling matches the names of our animations exactly, because these variables will control how Link behaves in-game. And once you've done that, hit apply and we'll save those values. Now, even though we've set those variables, they don't do anything yet. If you preview the game, you'll still see Link in the walk down animation that we set by setting his default animation to 1 earlier, even though it says idle down here. that's because we haven't connected those variables to any animations yet. So to fix this, we're going to create our first event. Head over to the Events tab, and if you don't see it, just select on the project properties and select your current scene, and this is going to open the event sheet that belongs with your scene. So in the event sheet, go ahead and click on Add New Event, which will give us a blank event with two sides, the condition on the left and the action on the right. For our first event, we don't need a condition, meaning our action will always run as fast as our computer allows. Now let's add the action. Click on Add Action, which will bring up a new tab to build the action. We want to affect Link, so go ahead and select him from the objects list. Now scroll down and find Animation by Name. Here we want to choose Set To because we want to force the animation to be whatever our variables dictate. And for the animation name, instead of selecting one from the dropdown, click on Use an Expression, which allows us to type in anything. This is where we'll bring our variables into play. Our animations are based on Link's action and direction variables. So we'll type link.action plus link.direction. This tells the engine to update the animation based on those two variables every tick, or really quickly. Let's head back to the scene and see what happens. Select on Link and look at the Properties panel. You'll see the animation is still set to 1, which means Link will be walking down when we start. But since our variables are telling the game to switch to idle down, that animation ends up taking effect essentially instantly. So go ahead and preview the game. Also, try changing the values. Set the action to walk and direction to right, and you'll see Link start walking to the right. If you set one of these two variables to something that doesn't match our naming convention though, you'll see Link go back to walk down. Since here we essentially fail to change the animation away from our default animation. If anything doesn't look right, double check your animation names match exactly with your variables, including case sensitivity. And once you're done experimenting, let's go ahead and reset both variables to idle and down, since this is how we want Link to be at the start. Now, we obviously can't expect players to manually type in the direction and action for Link each time they want to move. So we need to link, pun intended, those variables to specific key presses. For example, when the player presses the left arrow key, we want Link to start walking left, which means we need an event that changes that variable to the word left on the left key press. And then on release, Link should switch back to idle. So let's head back to the event sheet and make that happen. We'll start by adding a new event. You'll now have two events stacked on top of each other. Since the left sides of these events are flush, they are completely separate events with no relationship to each other, which is exactly what we need. So in the new event, we'll add a condition. As we mentioned earlier, the player presses the left arrow. We want Link to start walking left. So let's translate that into our event. Click Add Condition, start typing press into the search bar, select key press when it pops up, then fill in left for that key. Press OK, and then add action. This action is going to affect Link, so select him under our objects, scroll down to Variables, and choose Change Variable Value. Set the direction variable to left, and hit OK. But we're not done yet. When the left key is pressed, we also want to update the action variable to walk. Instead of creating a new event, let's copy the one we just made. Make sure you're not just clicking on the condition or action, but instead on the whole event, then copy and paste it. Now we'll edit the second event. Double click on the action to reopen it. And all we need to do here is change the variable name to action and the value to walk. Then hit OK. Our event sheet is in working order now, but it's not optimally set up. We have two events with the exact same condition, so we should condense these into one event. We can go ahead and drag the action from one event over to the other, and then delete the event with no action left. So why should we bother squishing these events together? From a developer's perspective, having duplicate events makes it harder to debug. If something goes wrong, we'll have to check multiple different events for the same issue. By combining them, we make the event sheet cleaner and more efficient, less confusing, and gives us just one place to check when we need to tweak something down the road. And now that we've handled left movement, let's add the other directions. Select the left key pressed event and copy-paste it 3 additional times. Change the key and the direction variable in each event to match the new movement direction. right and down. With a quick preview, on your key presses, you should now see Link changing to walk in each different direction. But we also need to stop him from walking when the keys are released. So back in our event sheet, we'll create a new event. And as we mentioned earlier, we want this one to be on key is released. Link should switch back to idle. So on our new event, add a condition for key released. We'll start with the left key. And we'll create an action to set Link's action variable to idle. And since Link is already facing left, we won't need to change the direction this time. Now, copy-paste this event, and on the condition, we're going to change the key released from left to up on our new event, and the action is going to stay the same since no matter what key you release, we're still going to want to switch to idle. And if you notice something familiar, just like last time, when we had two conditions doing the same thing, this time around we have two actions that are identical. So we can combine these again. This one's a bit more complex, since if we simply move the up condition into the left condition event, it'll require both conditions to be true at the same time, which isn't quite what we want. Instead, we need either or condition. So click Add a New Condition and search for or. Once you hit OK, there'll be a subcondition underneath or now, and you can drag and drop both the left and up conditions into the or sub-event. And this will make sure the action plays if either of those keys is released. Now we can go ahead and delete the second idle event and add the remaining directions to the or condition. Make sure all 4 directions are inside the or condition. If it looks like this, that is incorrect, as well as if it looks like this. All 4 of your directions should be tabbed in once, meaning inside of the or condition. And once you have it set up correctly, we can go ahead and preview, and now Link will switch between all his animations seamlessly. So we now have Link set up with all the necessary animations to move. The next step is to add the code that will make him move around the game world. While this might seem like a large task, GDevelop simplifies it with built-in behaviors. These pre-made tools save us a lot of coding and setup time. Let's jump into our scene. Double-click on the Link object to open its settings, switch over to the Behaviors tab, and add the top-down movement behavior 4 or 8 directions. This behavior brings with it several properties that we can tweak to get the movement just right for our game. Since we don't need diagonal movement, uncheck the Allow Diagonals option. Also, uncheck Rotate Object. Because we already have the animations in place which handle Link's direction, we don't want the behavior interfering with them. Next, we need to adjust Link's movement speed. We'll tweak the acceleration and deceleration settings, which control how quickly Link reaches his max speed and how smoothly he stops after releasing the move key. For example, if we set deceleration to 200 and keep max speed at 200, it would take a full second for Link to come to a stop after releasing the key. To make the movement feel more responsive, we'll set both the acceleration and deceleration to 4000, ensuring it stops almost instantly. Now let's find the right max speed for Link. I'll start with 64. But after a quick preview, I feel it seems a bit sluggish, so I'll go ahead and bump that up to 96. And you may ask, where are these numbers coming from? Since our game world is scaled to 32 by 32 tiles, each object in the game is going to be 32 pixels apart. So using multiples of 32 allows us to determine how many tiles Link can move per second. With a max speed of 96, Link will travel exactly 3 tiles every second, which feels good. Congratulations! Adding movement is no simple task, but to you, it is a simple behavior. You've completed the movement achievement. Next up, let's build our scene. Alright, let's start building out our scene. 1. Adding the ground. First, we'll begin with a ground object. Click Add a New Object, and this time, instead of selecting Sprite, choose Tiled Sprite. A tiled sprite is unique because as you drag the height and width, the image doesn't stretch. It repeats seamlessly without distortion. This makes it ideal for large areas, like our ground. Since our ground's going to be solid, you won't see the tiling effect this time, but it is good to know for future use. Go ahead and give the name Ground to our tiled sprite, then click Create with Piskel. Inside Piskel, we'll select a color that matches the pale brown of Link's floor. Click the active color at the bottom left of the screen. Then drag the color rainbow slider towards an orangish yellow and pick a shade that looks closest to the floor color. Use the paint bucket tool to fill the entire canvas with your selected color, then save your work. Back in our scene, drag out the ground object to stretch over the entire scene. Uh-oh, it looks like Link disappeared, but don't worry, he's just hidden beneath the ground object. 2. Adjusting Z order. To fix this, let's change the Z order of some objects. First, select the ground, since it's currently above Link and makes Link very hard to select. And we'll go ahead and set the Z order of the ground to 0. And this should make Link pop up on top of the ground, since his Z order should be 1. Though this varies if you created multiple objects, since the Z order is given as the number of objects is created. 3. Adding mountains. Next, let's bring some mountains into the scene. Click Add a new object and select Tile Map this time. Rename our tile map to Mountain Tile Map and set the tile size to 32. Now press Choose a File and select the Mountains Zelda PNG that you downloaded from my itch.io page. When the tile map loads, you'll see 3 mountain tiles, a full square, a diagonal, and a black door tile. Select the first 2 tiles, leaving the black door unselected. This will ensure the selected tiles have hitboxes, which we'll use later on to stop Link from walking through them. Click on Apply to save, and now let's start drawing our mountains. Go ahead and drag the mountain tile map into the scene to begin placing tiles. Since the tile map starts unselected, click near the stairs icon to pull up its properties. Now you can select tiles and start painting. Let's start with the square mountain, and you can see if you click once, you'll place a single mountain tile, or if you click and drag, you can fill the larger area within. Once set up, we can use the diagonal tile to fill in the corners, such as the area on the bottom left, and then we can use the flip to horizontally, vertically, or do both in order to fill in the other corners. If you need to replace any tiles, you can either use the eraser or simply click over the tile with the new tile you want to use. For this scene, create a map with 3 exits, 1 to the left, 1 above, and 1 to the right, and also leave a little bit of space for the cave entrance near the top exit. 4. Preventing Link from walking through mountains. Let's make sure Link can't walk through the mountains. Go to the Events tab and add a new event. For the action, select on Link and use the action Separate Objects. This requires an object that won't move, and we will add Mountain Tile Map. Looking at our events, you may have noticed that we now have 2 events with no condition again, and that we can combine them. At this point though, I do plan on adding a condition to the event in the future, so that way it's not always happening. So for now, I'm going to choose to leave them as separate events. And back on our scene, we're going to make one final Z order adjustment. Let's set Link's Z order above the mountains, so he appears to be in front when entering the cave later on. Since Link is completely covered by your tile map, it might be hard to select him. In order to grab onto just Link, go ahead and select off of your tile map and drag and drop your cursor so it fully covers Link, but doesn't fully cover any other object. This will allow you to select on Link and then move his Z order up. That way he's on top and you can select him easily from now on. Now give it a preview and admire your beautiful work. Now let's move on to creating the cave environment. First, some assets for the ground and mountains to reflect the darker setting inside. We'll repeat some steps we've used before by making a ground cave tiled sprite and a mountain cave tile map, but we'll go about creating this tile map in a different way. For the ground cave, create a new tiled sprite object and name it ground cave. Use black as the fill color and drag the object onto our scene directly below the starting zone, setting the size to 512 by 352. And that's all done. Now, since we want a new version of the mountain tile map, we can't load in the same image and alter it, because that ends up changing both images. Instead, we'll copy the old image and use it in a new object. Here's how we copy the mountain tile map. Open up the mountain tile map from earlier and click Edit with Piskel. Use the rectangle select tool to highlight the full 96 by 32 section of the tile map image. I prefer to cut the selection rather than copying, so I know it's in my clipboard when the image disappears. Then just cancel out of the editor. That way we discard all the changes to the original tile map. Now let's create a new tile map for our cave. Add a new object, naming it Mountain Cave Tile Map, and set its tile size to 32 by 32. Next, create with Piskel, then click Resize to set the canvas to 96 by 32. making sure to uncheck Maintain Aspect Ratio before resizing. Now paste the image from our clipboard into the Piskel editor, and we're ready to make some adjustments. For the cave's rocky texture, let's use a crimson color with a mix of red and orange, and we're going to want it on the brighter side. Once you have the color selected, select on the paint bucket with the swirl icon. This will allow us to recolor all matching pixels at once. Click on the lighter green rock to replace it with crimson. Then, without readjusting the rainbow slider, we're just going to move to a slightly darker shade, and we'll reuse this on the dark green parts that are remaining to replace those. There may be a few green pixels that didn't change, which means that they weren't an exact color match. Just fill those in manually, the darker ones with the same crimson color we currently have selected, and we can use the color picker tool to grab the original crimson shade and finish filling the remaining green areas. Once everything looks right, save your work, then set the hitboxes on our first two images, and click Apply. Now, drag the new mountain cave tile map into the scene, placing it over our ground object. Create a 2-tile deep border around the cave, with an entrance gap at the bottom for Link to enter through. With the environment in place, we need several new objects: the sword, the old man, and a fire animation. Create a new object for each, and remember for the fire, make sure to set the sprite sheet frame size to 32 by 32, as well as adjusting the animation speed to something appropriate and checking the loop animation to ensure the fire cycles continuously. Once the objects are created, drag them onto the scene. Leave some room above the old man for a text box, which we'll go ahead and add later. And that's it. Your cave is now ready for Link to enter and collect his sword. And while we're on the topic of scene building, let's add a few extra zones for Link to explore. First, we'll increase the size of our ground tile map to cover areas to the left and right of our current map. There are two ways to do this. We can either add a new instance of the ground object and drag it out, like we've done before, or we can simply stretch the existing one to cover multiple zones at once. Either method will work, but I'll stick to the current ground object since I feel it's a little quicker. Now, if you try to select the ground instance, you'll notice that the tile map keeps getting in the way since it's directly on top of it and the same size. So, a workaround for this is we can right-click on the ground object in our objects list and select Instances on Scene. This will open the properties for the selected instance. Make sure Keep Ratio is unchecked, since we don't want the height to change with it. Then we'll go ahead and set that width to 1536. Now, since the ground's origin is in the top left corner, resizing it expands it to the right, and also down if we were to adjust the height. So to account for this, we need to move the X position 512 pixels to the left, so we can go ahead and set that to -512. And now we're ready to start adding mountains and other assets to our new zones. Go ahead and select that mountain tile map that's already on our scene and start placing our new tiles. For the left zone, surround the top and the bottom with rocks, leaving a large opening to the left and a smaller one near the top right. Next, create a new tree object. And drag a few into the center of this zone. Then for the right zone, it's going to be filled mostly with trees, so we'll taper those rocks off right near the entrance. And then the main goal here is to make sure the entire bottom is blocked off with trees, and then the inside can just be spaced out to whatever feels right for you. Since we'll be moving so many trees here, to speed things up, you can use the Control and Drag feature, which just duplicates whatever you have selected. You can also click and drag to select multiple trees at once. Just keep in mind, whatever you drag over will only be selected if you select the entire object, which allows you to not select the ground and the tile map in this case. Additionally, Control plus clicking on an object will add it to your selection group. So you can use this to get more precise grouping. Once all the assets are in place, we need to make sure Link can travel between these areas. Right now, if he walks off the edge of the screen, he'll just kind of disappear. So to fix this, we need to move the camera as Link leaves the screen and determine which side he exited from. The goal here will be to detect when Link moves off the screen, and based on the side he exits from, smoothly pan the camera to the next zone. Fortunately, GDevelop makes this easy with the on-screen behavior. Go ahead and select the Link object, then go to Behaviors. Click New Behavior and search for Is On Screen. And this behavior will have no properties to adjust, but ends up giving us new events to use over on our event sheet. So let's head on over there and add the necessary code. Create a new event, add link as the object for the condition, and select is on screen. Set the padding to 0, click OK, then right-click the condition and select invert condition, which instead will allow us to detect when link is off screen. Next, right-click on the condition, hover over add, and select sub-event. You can also use Shift-D to quickly create sub-events. Add a total of 4 sub-events to this one parent event. These sub-events will only trigger if the parent condition is true, meaning they'll only run when link is off screen. Then we'll have to use each one of these sub-events to determine which side of the screen link exited on. We'll do this by comparing link's position to the camera, which stays at the center of our screen. Since our screen is 512 by 352, if the center of link's sprite is more than 256 pixels less than the camera's X position, that means he's off the left edge. On the other side, if link's center position is greater than 256 pixels, that means he's off the right edge. The same logic applies for vertical movement. If link's Y position is less than 176 pixels, then he'll be above, and if greater than 176, he's off the bottom. For each of these conditions, the action will be to move the camera to the center of the next zone, which is 512 pixels on the X-axis or 352 pixels on the Y-axis. In order to handle this, each sub-event would have to tackle one direction. The first condition will check if the center X position of link is less than the camera center X position minus 256, with an action to change the X position of camera to subtract 512. Then the next sub-event's condition will be the opposite. If link center is greater than the camera center plus 256, then we'd need to add 512 to the camera's position. Using the same logic for the Y-axis, if link is less than the camera center Y minus 176, then subtract 352 from the camera's position, if link is greater than the camera plus 176, then add 352 to the camera's position. Once it's all done, your code should look like this, and this will allow the screen to jump over to link's new zone each time you walk off the edge. But instead of having the camera jump instantly to the new zone, we'll add a tween to smooth the movement. Let's head back to the scene and create a new camera object. This will be a sprite, and we'll name it camera. Open it in Piscal and resize it to 32 by 32, and fill it in with a color for testing. We'll end up hiding it later. While in the camera's object properties, click Edit Points and change the origin to the same coordinates as the center. Then move over to the Behaviors tab and add the tween behavior. This behavior will allow us to smoothly change the object's properties over a set duration. For us specifically, we'll be using it to move the position. Hit OK, and then you can drag the camera object onto the scene. Its starting position won't matter because we're going to set that in the code to make sure it's precisely in the center. To do this, we'll have to go back to our event sheet, create a new event with the condition at the beginning of the scene. This ensures the event will only run one time at the start of the scene. And this event will set the camera's object's position to 256 by 176. I personally like to keep my beginning of the scene events at the top of the event sheet, so I'll drag this one up. Then, in the event below, which has no condition, set the real camera to follow the camera object. Now, instead of moving the camera directly, we'll use the tween behavior to move the camera object itself. Back in our previous event, with the 4 sub-events, go ahead and create a new action on the first sub-event, selecting on the camera object, and then selecting tween object X position. We'll give this a name called transition and set the target X position based on where the camera object currently is. In order to do that, we'll type in camera.x, open parenthesis, close parenthesis. That'll grab us the current X position, then minus 512 in order to give us the left movement. From here, we'll set the easing type to linear, meaning a consistent speed, and the duration to 0.3 seconds. After clicking OK, delete the old action and update the other 3 sub-events with similar logic. Once the code is ready, you should test out your game, walking in each direction. Here, you should now be able to see the camera smoothly transition between scenes. The only thing left to do now is to freeze Link's movement during this transition. So, once again, back in our event sheet, create a new event that checks if the camera's object's tween is playing. The name of the tween we're checking for is transition, spelled exactly how we named it earlier on. Then the action will be deactivate Link's top-down movement behavior. We'll also need to reactivate Link's movement behavior when the transition is over. So copy-paste this event and adjust the condition to detect when the tween has finished. Then change the activated to yes. Also create a second action, and this one is just going to remove the transition tween from the camera's object, since we're done using it for now. Then, back at the top of our event sheet, in the beginning of scene event, add another action to hide the camera object. Now, when you test, the camera will pan smoothly, freezing Link during the transition, just like you're used to. And if you've tested long enough, you might have noticed that Link can walk right through the trees, which of course is not okay. Luckily, we've already tackled a similar issue before, and the solution is just as easy. All we need to do is create another separate objects event. In the same event as our separate Link from mountain tile map, add an action that pushes Link away from the tree object. And now we have 2 actions that do the same thing to 2 separate objects, which works fine on its own, but as always, there's a cleaner way to handle this. Back in our scene, let's open the Objects Group panel. It looks like 3 stacked cubes. This will let us group multiple objects under a single name. Then, instead of adding individual events for each object, we can make a single event that applies to everything in the group. In the Objects Group panel, click Add New Group. I'll name mine Solids. Next, I'll go ahead and add all the objects I want affected by this group, which will be both mountain tile maps, the old man, the tree, and the fire object, which I just realized I forgot to name earlier. So after renaming my object to fire, I'll head back to the event sheet, and instead of moving Link away from individual objects, I'll change the action to move Link away from the solids group, and I'll delete the old redundant action. With this setup, Link will no longer be able to walk through any of the objects in the solids group. And if we want to add more solid objects in the future, we just need to drop them into the group with no need to adjust any events. Now that we've got the movements between zones working correctly, we need to create a way for Link to reach the old man inside the cave. Now the cave entrance itself is already set up and we can walk into it, but nothing happens yet. We need a way to detect when Link should move into the cave. I feel that collisions are always a simple way to handle these things, so I'll create a new object called Enter Cave. I'll resize this to 32 by 8 because I want Link to be most of the way into the cave before this collision happens. The Enter Cave object will remain transparent, so be careful when placing it as you won't be able to see it, though an outline will appear around it if you hover over it or if you have it selected. If you happen to lose track of it, you can always use the right click on the object and select Instances on Scene to find it. Go ahead and drag the Enter Cave object onto the cave entrance. It should sit on the upper half of the cave door, but if the grid is snapping to the lower half, just adjust the Y position and the instance properties, or use the arrow keys on your keyboard. Now we need to figure out where Link should appear inside the cave. We know we want him to spawn at the bottom left cave entrance. So feel free to just drag and drop Link there, and then check his X and Y position. This way you know exactly where you need to set it in the code. While doing this, I also noticed that Link is underneath the ground, which is a Z order of 4, so I'll have to update Link's Z order to 5 to make sure he stays on top. Now back in the event sheet, I'm going to create a new event. condition, Link is in collision with Enter Cave. First action, set Link's position to 224 by 672. And the second action is set the camera's position to 256 by 528, which we calculated that position by just adding 352 to our current camera position. And with that, we can send Link into the cave. Now, of course, we want to spice things up a bit, so let's add an animation for when Link walks into the cave. Open Link's object and add a new animation named Walk Downstairs. We'll use Piskel to create this, so drag your existing Link animation into the editor, then remove all frames except the ones you used for the walk-up animation. Quick reminder, Piskel can be finicky, and this will be one of the larger edits we'll make in the editor. So feel free to save and reopen frequently to avoid losing any progress. Our goal is to create the effect of Link walking down steps by copying the existing frames several times and moving them progressively lower on the screen. Start by copying each frame. Make 3 copies of the shield frame and 2 copies of the sword frame, which gives us 7 frames in total. Next, we'll arrange the frames so that the shield and sword animations alternate with each other. The final order should interweave them like this: shield, sword, and so on. Now we'll start shifting the frames down to simulate descending steps. First, focus on the shield frames. Frames 1, 3, 5, and 7. Use the hand move tool to drag each shield frame down. Feel free to turn on onion layer to help keep everything aligned. Also, I find it helpful to pay attention to the coordinates at the bottom right corner as you drag. Just get the starting position of when you click and then add the amount of pixels you're dragging to figure out where you should drag to. So frame 1 will move down 7 pixels. Frame 3 will move down 14 pixels. Frame 5 will move down 21 pixels. In frame 7, we will delete the image, so it's just a blank frame. Next, we'll adjust the sword frames to give Link a slight upward bob as if he's stepping off the edge of a step before continuing down. So each one of these should be 1 pixel higher than the shield frame above it. Frame 2 will be 6 pixels down, 4 will be 13 pixels down, and frame 6 will be 20 pixels. Next, we need to erase a few pixels off the bottom of the animation using the rectangle tool and selecting the bottom 3 pixels of the frame. Once selected, you can just click through each frame and hit delete. Once you're done, save your work and set the animation speed to 0.24 seconds per frame, leaving loop option unchecked since we only want the animation to play once. Now that the animation is ready, let's switch over to the event sheet. Instead of just teleporting Link when he touches the Enter Cave object, we'll trigger the new animation and have Link walk down the steps. Add an action to the event where Link collides with Enter Cave. The action should set Link's animation to the new walk downstairs animation. Once the animation finishes playing, we'll want to move Link and the camera to their new positions. But because our movement system constantly switches Link's animation between walk and idle, we'll need a way to override that and force the stair animation to play uninterrupted. We'll also need to temporarily disable the player's control. To start, create a new event with conditions that check if Link is playing the walk downstairs animation, and additionally if that animation is finished. Once both conditions are met, we can just drag and drop the 2 position change actions for Link and the camera that we created earlier on the event above. Now this will move Link and the camera once the animation completes. In theory, this should all be ready to go, but since our movement system overrides animations, the walk downstairs animation never fully completes, so our new event is never met. To fix this, we can create a global variable to block the other animations while Link walks down the steps. Open up the project manager and go to Global Variables. Add a new variable called Stop Animations. Set the type to Boolean, also known as true or false, and leave it at false by default. Since we want Link's movement and idle animations to play by default, and our Stop Animations variable is false by default, we'll want to check to see if that animation is false before playing those. So scroll up to your movement animations and right-click somewhere, and select Add New Event below. In this new event, add a condition to check if Stop Animations is false. Now, drag all of your movement events into this new event as a child event. They should appear indented beneath the Stop Animations event. And in total, you should have 6 child events here. If you were to preview the game now, there should be no changes to the game since we are setting this up to run as it did by default. To help keep things a bit cleaner, click on the drop-down arrows next to the parent events, we have 2 now, and collapse them. This will just make it a bit easier to see my event sheet for you. Next, let's head back to the Enter Cave Collision event. We'll add an action and set stop animations to true. This will prevent any movement or idle animations from playing while Link walks down the stairs. Now, in the event where walk downstairs animation finishes, copy the stop animations action and change it to false. This will restore the normal animations once the stair animation is complete. Finally, we also want to stop the player from controlling Link while the animation plays. Since we already handled this once during the camera tween, we can just copy the behavior deactivation action from the tween event into our Enter Cave Collision event. Then also copy the behavior activation action into the event where the animation finishes. With everything set up, now's a great time to give it a test, and Link should walk smoothly down the steps, and the camera will then move to the new position inside the cave. Player input should be halted during this animation, and return to normal once you get to the cave. Great, now that we're inside the cave, we need to take care of 3 things. The text that pops up about taking the sword, a way to collect the sword, and a way to leave. First on the list, let's add that text. Create a new text object and name it text sword. Set the size to 24, color to white, and alignment to centered. Type in the message you want displayed. Then choose a font. The asset store has loads of free ones. Then drag the text object onto the scene and stretch it to fit the area you want. This won't change the size of your actual text, just the box in which the text can be displayed. With the text set, let's add a typewriter effect. Double-click on the text box, navigate to Behaviors, and add Auto Typing Behavior. In the event sheet, once Link enters the cave, we'll want the text to start from scratch and type out. To do this, just add a new action, affecting the text object to restart typing. Next, we'll work on collecting the sword. At its simplest, we can create a new event that deletes the sword when Link collides with it. On collision between Link and sword, delete sword. While this doesn't change gameplay yet, it gives the visual effect of picking up an item as it disappears on contact. Let's make this a little more interactive though, and add a new animation to Link for when he collects the sword. Open the Link object and add a new animation called Collect. We'll add Link sprite sheet again, then delete all the frames except for the final one. We're going to want to duplicate this final frame so that we have 2 copies of the same animation. This won't change the appearance of the animation, but it does give us an animation duration, which lets us use the animation completion, like we did with the stairs, as a timescale without needing to add additional timers. Set the time between frames to something slow. I'll use 0.7 seconds. Back in the event sheet, where we delete the sword, let's add a new action to change Link's animation to collect. During this time, we'll want to lock the player movement until the animation completes. So on collision, add the deactivate movement behavior for Link, which we've used before, so we can copy paste this from previous code, and this will stop the user's input. Then, to prevent the usual animations from playing, copy paste the stop animations action as well. Next, we'll create a new event to check if Link's animation is collect and that the animation is finished. This will be the moment that we want to delete the sword. So, drag and drop that delete sword action to the new event. At this point, also reactivate Link's movement and restore regular animations. With this, Link will collect the sword, but we still need to set the sword above Link's head. So, to place the sword in Link's hand, add an action to the collision event to set the sword's position relative to Link's. Set the sword's X position exactly to Link's X position using link.x open and close parentheses. Then for the Y position, set it to link.y open close parentheses, and then we want to push it up a bit higher, so we'll also have -16, which will just push it up 16 pixels. And with that, Link will hold the sword above his head, and his movement animations will resume once the collection animation completes. And if the animation lasts too long or too little, then you can simply adjust the 0.7 second delay on Link's collect animation. Now, we just need a way to leave the cave, which should happen as Link walks downward out of the stage. To start, let's create a new sprite called Exit Cave. Set the dimensions to 64 by 32 and fill it in with any color since it will be hidden from the player's view off screen. We'll place this just below the cave exit so Link collides with it as he attempts to leave. On contact with Exit Cave, we'll want to switch the camera back to the starting zone and animate Link as he walks up out of the cave. First, the animation. The walk upstairs animation will work similarly to the walk downstairs animation, but in reverse. We'll use the walk down animation frames so Link is facing the player, and we'll start with only the tip of his head showing. Then Link will gradually bob upwards onto the stage. When setting Link's position, Link will start 9 pixels lower than the cave opening, which avoids triggering our hidden object enter cave. Otherwise, Link would head straight back into the cave. So to make up for this lower starting point, we'll delete the bottom 10 pixels of each frame, and the final frame will end up slightly higher than the usual position to align with Link's normal animations. Once the animation is ready, name it Walk Upstairs, and head to the event sheet to set up the exit sequence. In the event sheet, create a new event for Exit Cave Collision. First, set the camera object back to the starting zone at 256 by 176, which technically fails at this moment. As you may have noticed, our Stop Animations event also pauses the camera from following the camera object. This wasn't intentional, it just happened to be grouped with other animation actions that needed to halt during this time. So to fix this, we want to move the center camera on camera object action to a conditionless event outside of the Stop Animations scope. And the empty event just below that pushes Link away from solids is a great spot. Next, we want to position Link. The cave opening is at 96 by 32, but we need to be underneath our 8 pixel enter cave object. So instead we'll use 96 by 41. Next, we'll set Link's animation to walk upstairs. And as we've done before, we'll block both the top-down movement behavior and set stop animations to true. Then, in a new event, once walk upstairs completes, we'll remove these 2 restrictions. Now, looking over our event sheet, we have several similar conditions across different events that can be combined into a single streamlined event structure. Currently, we check if Link's animation has finished in 3 separate events, and each of these has its own actions based on the specific animation that was playing. So here's how we'll consolidate these. We'll create a new event with the condition animation of Link is finished, since this is the matching condition between all of the different events. And this event will handle all the actions that should occur regardless of what animation was playing, which includes both reactivating top-down movement and setting stop animations back to false. Next, for the animation-specific actions, we'll have to create sub-events for each of the events we made. So our first sub-event would be walk downstairs animation is playing, and it'll need the remaining 3 actions that haven't been taken care of yet: changing Link's position, changing the camera's position, and restarting typing. Next, a sub-event for if Link was playing collect, and this one will only need delete the sword. And finally, our walk upstairs animation was only created in order to release the behavior and animation restrictions, which we already cover in our parent event. Therefore, this one doesn't need to be created at all. And now, with this new setup, we'll keep the event sheet organized and prevent duplicate code. And now Link walks out of the cave, the camera resets, and the animation sequence will give us a smooth and polished exit effect. And let's take a moment here to pat ourselves on the back. A huge congratulations to mastering scene transitions. You now have the tools to seamlessly move from one map area to another, or teleport deep into a cave. With these techniques, you're ready to expand your game and build a full, immersive world for Link to explore. Keep going and enjoy bringing your vision to life. Alright, it's time to dive into combat. First, we'll set Link up with 2 key updates. 1, some attack animations, and 2, a health system. Let's start with the attack animations, as animations are already a familiar territory for us. Just like we did for walk and idle, we'll create a new animation for each direction. Open the Link object and add animations for attack up, attack right, attack left, and attack down. And just like we did in the beginning with walking and idle, we'll attach these to Link's variables for both direction and action. While creating each of these animations, you'll notice that each of the attacks has a different number of frames, which would result in a varying attack time depending on the direction. So, to keep things consistent, we'll want to adjust the frame speed so that every attack finishes in 1.2 seconds. So, for the animations with 6 frames, set the frame time to 0.2 seconds. Animations with 5 frames, we'll set it to 0.24, and for the animations with 4 frames, we can set it to 0.3. Alternatively, we could also achieve this by adding or removing frames from each of the animations so that they all have the same total. Alright, now that Link has his animations, let's code his ability to use them. As mentioned earlier, we'll use Link's variables to control his animations. In the event sheet, locate the code that manages Link's animations with the action and direction variables. Right-click on the parent and go to Add Sub-Event, and we'll go ahead and base the attack on the spacebar. So, set space is pressed as the condition, then add an action that sets Link's action variable to attack. With the current setup, this works to some extent. However, as it stands, you will have to move between each attack in order to reset the action variable, and if you press a movement key during an attack, it can be cancelled mid-animation, since the top-down movement and our stop animations are both not in effect. So let's go ahead and fix both these issues. First, we'll ensure that once an attack animation completes, Link returns to idle. We already have code handling animation completion, so head down to that and then add a new sub-event within this section. Set a condition to check if Link's current animation by name contains attack. This will cover all of our attack animations. To set this up, change the condition operator to contains, and you won't be able to use the prefab names of your animations, so you'll have to click on expression and then type in attack. Now, if this condition is met, we'll want to reset Link's action variable back to idle. Now, Link will be able to attack multiple times in a row without needing to move between attacks. Next, to prevent the player from canceling attack animation prematurely, we'll apply our trusted technique, stop animations, and disable top-down movement. And we'll want to do this once Link initiates an attack. So copy-paste those 2 actions and paste them up in our space key is pressed event. At this stage, our code is super close to working. But there's a bug. Run a test and see if you can spot it. When attacking, everything works as expected in all directions. Link will remain frozen until the attack finishes, then regain control. However, if you press space while moving, our code disables animations and top-down movement. Typically, the attack animation's end would restore stop animations, but if Link was moving when he attacked, the walk animation overrides it, causing stop animations to stay true indefinitely. We could add complex checks to detect this situation, but there's a simpler fix. Move the space key is pressed event above the child event that changes Link's animation based on his action variable. This prevents the walk animation from triggering during the attack sequence, avoiding the bug altogether. And all this was a quick reminder to make sure you debug thoroughly, and keep in mind that the event sheet executes code from top to bottom, so sometimes a simple change in the order is all you need for things to work out smoothly. And since we're in here working on Link's attacks, let's add a global variable called canAttack as a boolean with a default value of false. Then in our code, where spacebar is pressed, we want to check whether that variable is true before allowing Link to attack. This way, pressing spacebar won't do anything unless that value is changed. Now in our event that happens on collision with the sword, we can go ahead and set that variable to true, which will then give Link his ability to use attacks. So, in turn, this will make it so Link is required to speak with the old man and get his sword before being able to attack. Alright, let's set up some enemies for Link to attack. In the original Zelda, enemies respawn whenever you enter a new area, even if they were previously defeated. To replicate this, we'll use an enemy spawn object, instead of just directly placing the enemies on the map. This way, when the camera pans to a new area, any spawn objects on screen can generate our enemies. Start by creating a new object in the scene for the enemy spawn points. As always, the size will be 32 by 32, and then fill it in with any color so they're easier to find after they've been placed on our scene. Go ahead and name this spawn enemy, and then head over to the behaviors and add is on screen behavior. Now we can drag 3 instances of the spawn enemy object onto our scene on the map area to the left of where Link starts. Now that our spawns are in place, let's create our enemy object. Add a new object named Red Octorok and set up its sprite sheet. Remove all the frames except for the 2 frames where the Octorok faces left, then flip these frames so they face right. Starting the Octorok facing right aligns the default angle of 0 degrees, making future rotation simpler. And since the Octorok's direction doesn't affect its appearance, we'll use only this one animation and control its movement with angles. As always, slow down that animation speed a little and set the animation to loop. Now, let's add the code to spawn enemies when you enter a new area. First, let's hide those spawn enemy objects. We can do this at the beginning of scene event, which makes sure it's handled only once per game. I just copied the hide camera action and pasted it in right beneath, and then changed the object to spawn enemy. Next, scroll down to where the camera tween finishes, since this will be where we're setting up our enemy spawns. Right-click and add a for each object event. Drag this event into the tween is finished event as a sub-event. Then change the empty object to spawn enemy. Inside this, for each spawn enemy sub-event, add a condition to check if spawn enemy is on screen. If this condition is met, add an action to create Red Octorok at the spawnEnemy.x and spawnEnemy.y positions. And just to clarify, this code functions as follows. When the camera tween completes, it checks each spawn enemy object. If the current spawn enemy object it's checking is on the screen, a Red Octorok will be created at that spawn point. Once the engine finishes checking every spawn enemy, then it's done. And now, when Link enters the new area, 3 Red Octoroks will be waiting for him, ready to engage in battle. Alright, now that Link is set up with an attack animation, and we have enemies, let's set up an interaction so that when Link attacks, it affects nearby enemies. We'll start by creating a hitbox for Link's attacks. During the attack animation, this hitbox will appear briefly in front of Link and then disappear. If it collides with an enemy, they'll take damage. First, setting up the hitbox. Create a new object called Attack Box. This will be size 16 by 16 pixels. We'll draw an arc from the top to the bottom, reaching out towards the right side. I want my attack box to be visible, so I'll color it appropriately. However, if you want it to be invisible, as it is in Zelda, you can hide it, which will happen later in the code. Resize the attack box sprite to 32 by 32. But first, uncheck the Resize Canvas content, and also anchor the image to the center. Once you resize it, you should see a smaller looking image in the center of your frame, and then you can go ahead and save this. Next, we'll need to code the attack hitbox. Head over to your event sheet and create a new event to check if Link's animation by name contains the word attack. Now we already have an event like this, but the parent event checks that the animation is complete, and we are looking to create our attack box mid-animation. So we'll need a new event for this. Next, we'll add another condition to check if the current frame is greater than or equal to 1. This ensures the attack box appears while Link is swinging down in his animation, which is the second frame, but since we count frames starting at an index of 0, we have to call it by the first frame. We'll also add a trigger once condition to ensure the hitbox only appears once per attack. For the action, create the attack box. We'll use position 00 since we'll be changing this depending on which direction Link is looking later on in this event. I'll also set the opacity to 100, which is around 40% transparency, but if you want it hidden, you can set the opacity to 0 or just use the hide object, like we've used for the camera. But if you are going to hide it completely, I recommend keeping it visible until you are done testing each direction. Alright, next up we'll be positioning the attack box based on the direction Link is facing. We'll add 4 sub-events for this, 1 for each direction Link faces. Each one of these sub-events will have its own condition checking if the animation by name contains the word right, down, left, or up. For the actions, in the right one, set the attack box position to link X plus 12 and link Y, which will just shift it slightly to the right of link. For the down one, we'll set the attack box position to link X and link Y plus 12, which will push it slightly further down than link, and we'll also set the angle to 90. In the left one, we'll set the attack position to link X minus 12 and link Y, and then angle it to 180 degrees. And finally, for the up one, we'll set the attack box position to link X and link Y minus 12 with an angle of 270 degrees. So as of now, we can attack in all directions, but the attack boxes stay forever, which 1 would affect enemies that walk into it, and 2 will slow down the game, so we need a way to clean these boxes up. This also includes people who have hidden their attack box. Just because the object is hidden does not mean it is not there. So back in our last event, up in the parent actions, add a new action to start or reset an object timer. This will be for the object attack box, and we'll give it the name delete. So now each time we create this attack box, it'll start with a timer. And under a new event, we can create a check for if the attack box timer delete is greater than 0.2 seconds. And if so, we can just go ahead and delete that attack box. So now we will create an attack box and delete it after 0.2 seconds. Great, now let's set up some code to knock back our red Octoroks when we hit them. Under a new event, we'll check for a collision between attack box and red Octorok. Additionally, we'll want to add that trigger once condition as well. For the action, we'll apply a force by angle. For the angle, we'll type in angle between positions, which is a function that calculates the angle between 2 points. Our first point will be link X and link Y, and our second points will be red Octorok.x and .y. Make sure each of these is its own function, so it has the open and close parenthesis, and they're each separated with a comma. And we can go ahead and give this a speed of 96 and set it to permanent. And for our other action, we'll create another timer. This one will be for red Octorok, and we'll call it knockback. Finally, we'll want a way to stop the knockback. Under a new event, we'll want to end our knockback depending on 2 different things. 1, if it's been moving for too long, or 2, if it hits a solid object. So under a new event, create an OR condition, and then inside that OR condition, first check if red Octorok's knockback timer is greater than 0.6 seconds, and then second, check if red Octorok collides with a solid. Then for our action, we simply remove all forces, and this in turn will stop the knockback effect. Now that we're capable of knocking around our Octoroks, let's take this a step further and make them capable of being damaged. First, open the red Octorok object and add the health behavior. In order to guarantee we prevent the same attack box from hitting them multiple times, we'll set the damage cooldown to 0.25 seconds, just slightly longer than the attack box duration of 0.2 seconds. Since red Octoroks are always defeated in one hit in the game, set their starting and maximum health to 1. This behavior has a lot of extra properties, but they aren't needed for this project, so we can leave the advanced options alone. Next, open links object. We'll add a new variable here called attack. This will be a number variable with a default value of 0. Now, let's head over to the event sheet and upgrade Link's attack power when he collects his sword. In the sword collection event, add a new action to set Link's attack variable to 1. Later, when Link collects more powerful swords, you can adjust his attack power by updating this variable. Here's a quick tip though. If players can collect swords out of order, you'll want to add a condition to ensure the upgrade only applies if the new sword is stronger. For instance, we could add a subcondition to check if Link's attack variable is less than 1 before setting it to 1 here. Now, let's make the attacks deal damage to the enemies. In the event where the attack box collides with red Octorok, Add an additional action to apply damage to the Octorok using the health behavior. For the damage points, use Link's attack variable by referencing link.attack. Any sub-event after dealing damage, check if the red Octorok is dead. If it is dead, add an action to delete the red Octorok. This setup ensures the Octorok is either knocked back or deleted, depending on whether it survives the attack. Since this means all of our enemies will now be defeated in a single hit, let's introduce a tougher enemy, Blue Octoroks. Create a new object called Blue Octorok, use the same sprite sheet as before, and keep only the 2 frames of the Blue Octorok facing left. And again, flip those frames so they face right. Then set the animation speed to 0.24, and make sure the loop box is checked. Add the health behavior to this object as well, again with the damage cooldown of 0.25 seconds, but with a starting and maximum health of 2. Save the object when done. To make managing enemies easier, let's group them together. Inside of our Groups panel, create a new group called Enemies. Add both Red and Blue Octorok to this group. Now we can adjust our code to work for all enemies in the group. Use the Search and Replace tool, Ctrl F, or the magnifying glass icon in the top right will open it for you. Search for Red Octorok and replace it with Enemies. This will update all relevant events to work with the group instead of just Red Octoroks. There are going to be 4 different events that are updated, and you can scroll through each of them to verify the changes. This allows everything that we built with Red Octoroks to work seamlessly with any object added to the enemies group. With one small exception, our spawn enemy does not have a way to spawn more than just Red Octoroks right now. Since currently it is just spawning enemies, which is a group, it'll just pick the first enemy in the group and continue spawning Red Octoroks for us. So let's tweak that. Open the spawn enemy object and add a new variable called enemy. This will be a text variable with a default value of Red Octorok. Be mindful of capitalization as this field is case sensitive. Go ahead and close out, then drag a new spawn enemy object onto our scene alongside the existing ones. Select on the solo instance of the object we just dragged onto the scene, and inside the properties, change the variable of enemy to Blue Octorok. Now we should have 3 spawn enemies with Red Octorok and our new spawn enemy with Blue Octorok as the variables. Back in our event sheet, find the event that creates enemies at the spawn enemy objects. We'll update this event with a new action called create object from its name. For the object name, use spawnEnemy.enemy, which will reference the variable stored in the current spawnEnemy instance. The X and Y positions will remain as spawnEnemy.x and Y, and then once this is done, you can delete the old action that created only the Red Octoroks. Now when you explore the map, the spawn points will dynamically create different enemy types based on their settings. And now that you have both enemy types, you can go ahead and test the different damages and verify everything is working so far with your enemies. Now, if you've done sufficient testing, you might have noticed a small bug. If you leave a zone with enemies and come back, the previous enemies never clear, and the new ones stack on top of them. So, to fix this, we need to clear out our existing enemies before spawning new ones. In the parent event, just before we spawn enemies, simply add an action to delete all enemies. This ensures we start with a clean slate every time we enter a map area. Now, let's set up that health system for Link. First, we'll open up Link's object and add the health behavior. Set the damage cooldown to 1 second, which will give players a moment to recover after taking damage. Then set both the starting and maximum health to 3. Close out of Link, then add another object to the scene, and go ahead and use the asset store to find Pixel Heart Bar, which will serve to show Link's health display. To make sure the health bar stays visible regardless of Link's location, create a new HUD layer. On our scene, open up the Layers panel. It's on the top right and looks like stacked squares. Then add a new layer called HUD. Objects on this layer will remain fixed on screen, unaffected by the camera, since the camera is on a different layer. You can click on HUD to make it the active layer for new objects. Or, since I end up using the other layer more often, I'll leave my default layer unchanged. Now, drag the pixel heart bar onto your scene and open up the instance properties for the heart bar. Here we're going to set the width and height to 96 by 32. And if, like me, you didn't change your default layer, you'll also want to update the layer under Properties. Now double-click on the object to open the object properties and adjust the following settings. First, we'll set the unit width to 32, then ensure all of the following: fill bar, and background dimensions are all 96 by 32. Then you'll have to edit each of the images in Piskel and double their size, and make sure Resize Canvas Content option is checked when you resize the images to 96 by 32 as well. Now we can head back to the event sheet, and we'll link the health bar to Link's health. Up near the top of our event sheet, we have a condition-free event. We're going to go ahead and add a new action to set the heart bar's value to link.health. This ensures the health bar always reflects Link's current health. Next, we'll create an event to apply damage to Link when he collides with the enemy. In a new event, create a condition if Link is in collision with the enemy's group. Then add an action, apply 1 point of damage to Link. Now in Zelda, different enemies deal different amounts of damage. Red Octoroks should deal half of a heart, while Blue Octoroks will deal a full heart. So to implement this, let's add a variable named attack on both enemy objects. Attack will be a number variable, and we'll set Red Octoroks to 0.5 and Blue Octoroks to 1. Then, back in our event sheet, update the damage action to apply enemies.attack instead of the flat 1. Now whatever enemy collides with Link will deal their attack variables worth of damage. Now let's give our user some visual gameplay feedback when Link takes damage. First, knockback. Since we've already done knockback for the enemies, let's start out by copying that code and then give it a bit of a tweak for Link. So we'll change the object to Link. Next, change the force to instant and the value to 2000. Now instant force only lasts 1 tick, so this will push Link back by roughly 2000 divided by 60. So it's not as big as it looks. And then of course this was originally built to knock the enemy back, so our angle is in the opposite direction. And we can reverse this by simply adding 180 to the current angle calculation. Next, we can make Link flash when damaged. To do this, let's open up the Link object and add the flash color tint behavior. Additionally, we'll go ahead and add a small camera shake, which we can get to under Project Manager, Extensions, and then add the camera shake extension. Now let's head back to our collision event. We'll create a sub-event here to check if Link has just taken damage. And if that's true, we'll add the following actions. First, we'll make Link flash using the flash color tint behavior. For damages, I prefer a white flash, but that's not available since white resets the colors, showing the original color. So we'll use a gray tint here, and we'll have a duration of 0.5 seconds. Next, we'll add a shake camera action, and we'll have a 0.1 second ease, both in and out, and a total duration of 0.4 seconds. And then next, we can drag the knockback action down into the sub-event as well, so it only triggers when damage is taken, and is ignored during the 1 second of cooldown damage that we set inside Link's behavior. And finally, we can set up something to happen if Link runs out of health. Let's create a new event, then using the health behavior, if Link is dead, add an action to change the scene, and reset it to untitled scene, which is our current scene, and we'll just reset everything. Now, when the scene resets, all objects will return to their default states, but global variables will persist. This means we'll retain our 2 values, can attack and stop animations. But all of our other variables, like Link's attack, will be reset to the starting value. This means that currently if Link collects his sword and then dies, he'll still be able to attack, but we will never have hit the event that gave Link 1 attack. So under our beginning of scene event, let's make sure if Link has can attack, he also has his extra damage. So let's add a sub-event, then we'll check if can attack is true, and if it is, we can set Link's attack variable to 1, so he retains his 1 damage. Last up, let's make our enemies move and fire projectiles. The AI for Octoroks is fairly basic. They always move unless they stop to fire. They don't track Link, but move randomly, picking a direction and sticking to it for a short time unless they hit a solid. To achieve this, we'll build a simple state machine, and when triggered, each Octorok will roll a random number between 1 and 5, which determines the next action. They'll either move in one of the 4 directions for 1 through 4, or fire a projectile if they roll a 5. If the timer runs out or they collide with a solid, then they simply roll again. To avoid an extra difficult starting state, we'll ensure the Octoroks first load after a scene transition, and their initial state is limited to only movement. 1 through 4. So let's set up our Octorok group and state variable. Start by grouping the Octoroks separately from the enemies. While we already have an enemies group, this group includes all enemy types, and not all of them will share the same AI. So we'll create a new group called Octoroks, and add both the red and blue Octorok to it. When creating the group, you'll be prompted to set group variables. Here, we can add a new variable called state, which will be a number with a default of 0. And this variable will track each Octorok's current state. First, we'll roll for the initial action. Let's create a for each object event for the Octoroks group. Add a condition to check if the state is 0. This ensures that each Octorok rolls for a new action only once after the scene loads. And for our actions, we'll set the state variable to a random in range of 1 to 4. And an additional action to start the object timer, and we'll call this change state. At this point, let's verify that the roles are working correctly. We'll take our first look at the preview and debugger feature, located next to the preview game button under the dropdowns. Let's walk over to the scene with our enemies, and on the debugger, click refresh. At the time of clicking, this creates a free state of the game and allows us to examine our state variables for our Octoroks. Each one of them should have a random number between 1 and 4, with none of them remaining on 0. Debugging is invaluable for confirming that your logic is behaving as expected and spotting any issues early on. Back in our code, we can create a for each Octoroks event and add 5 sub-events, one for each state 1 through 5. So if our variable state equals 1, we'll want to angle our Octorok to the right, which is our initial angle. So this will be an angle of 0. Then state 2 will angle downwards, or 90. State 3, angle left, or 180. And state 4, up. We'll additionally want to add a force in the same direction. Since this code is going to happen over and over again, we'll want to set it as an instant force. And we'll simply put the Octoroks.angle as the direction with a speed of 72 pixels. Then state 5, we'll want to pick a random direction out of our 0, 90, 180, and 270. And we can do this by using random in range 0, 3 and multiplying it by 90. We'll also only want this to happen once. So we'll add a trigger once condition as well. And this will prevent the firing from happening repeatedly. Now we need a final sub-event to re-roll the states. Again, we wanted to do this under 2 different conditions, so we'll want to start with an OR condition. And the first condition in the OR will be the change state timer is greater than or equal to 0.5 seconds. Then the other condition will be if Octorok collides with a solid. Then for the actions, we'll reset the change state timer and re-roll with random in range 1 to 5, which can now include the firing state. Next, we have a few collision and movement tweaks. To prevent the Octoroks from walking through solids, head up to our conditionless event and copy the move link away action from earlier. And we'll just update it so that it works for Octoroks. Also, if you pause to test a bit, you may have noticed that Octoroks occasionally get stuck on solids. When we created our enemy knockback, we have an oversimplified event with an action that stops all forces. Since we're using a force to move, once they get stopped once, they end up never moving again. So in this event, let's add an additional condition to check if the knockback timer exists. And we can do this by verifying that knockback is greater than or equal to 0. Then in the action, we'll also delete the knockback timer. That way it requires the enemy to be hit again before giving the knockback timer back to the object. Alright, let's add projectiles. Add a new object and head back over to create from scratch. We'll call this object projectile and it'll be a size of 12 by 12. Just draw a simple and sloppy circle in light brown and then shade around the edges in a dark brown. Next, we can head over to both the red Octorok and the blue Octorok, and we can edit their points by adding a new point called projectile. I'll create mine at 1816, right between the eyes. And this will be the point at which we fire the projectile. Additionally, on our projectile object, we want to move the origin to the center. And finally, once again on both Octoroks, go ahead and add the fire bullets behavior, as well as the stay on screen behavior, which will stop Octoroks from wandering off. Let's head back to our event sheet to code the projectiles. Back in our state machine, finish the state 5 actions. We'll add a wait 0.2 seconds action. Then, using the fire bullets behavior, we will shoot our object projectile using the position octoroks.pointx, and then entering the name of our new point, projectile. Again, we'll do the same for point y. And then we can set the angle that we want to fire, add our Octoroks angle, and set the speed of the projectile to 72. Finally, we can adjust the projectile's z-order to appear beneath the Octorok by setting its z-order to Octorok's z-order -1. And last up, we need to make the projectiles deal damage to Link. So back on our scene, we can add the projectiles to our enemies group, allowing them to inherit attack logic. Then, back in our code, since our projectiles are now an enemy, they now have a variable attack, and when they're created, we can set their attack to the same attack value as the Octorok that fired them. And with this, you now have fully functioning Octoroks to battle with Link. I did make one quick tweak behind the scenes, cutting the time in half between all of my attack animations for Link. This small adjustment made the animations feel much smoother and more responsive. Now, before we wrap up, I do want to take a moment to thank all my loyal members. Your support means the world to me. And additionally, an extra thank you to RENDEV for helping me with the sprite sheets, which were then shared to all of you. And for all you viewers, if you made it this far into the video and are looking for a way to show your appreciation, I encourage you to check out that memberships page. Your contributions help me continue creating content like this. If donating isn't an option, no worries. You can still show your support with a like and a comment. Let's feed that algorithm. By the way, if you did make it this far, congratulations, especially if this is your first time creating a game or opening up GDevelop. This tutorial packed in a ton of information, and I'm honored that you chose me to guide you through it. I hope to see you around for future projects, but until next time, peace.